Section 2.5 is where we start to talk in a little bit more detail about the structure of the atom and how it's put together. J.J. Thomson again, remember him from the previous section as the person who did the first work on what an electron was and measuring electrons. He had a model of what the atom must look like, and in his model what we had was individual electrons, because we knew that those were little particles at this point. And inside this kind of solid sphere of positive charge. That was this early but incorrect view of the electron. They called this the plum pudding model. It'd probably be better understood in more modern terms as kind of the book refers to it as the blueberry muffin model, where the main part of the blueberry muffin is the positive charge, and that the electrons are actually just little blueberries sprinkled out through different spots. Now, Rutherford, another scientist, performed another experiment where he took a source of radiation, and radiation was not well understood at this point, but we knew that alpha particles could shoot out, which were about the size of helium atoms, and we could fire those at a piece of gold foil and then use a detector grid all around it to see where those different particles would go. So the alpha particles hit the foil. If the atom was like this plum pudding model, we'd expect things to go through. So that's our predicted result. Plum pudding model, big giant particles, big giant radiation particles come through and they just splash right through the atom. There's not enough substance in a small enough area to really provide density enough to deflect these particles. Now in reality, what they actually saw, and they performed this several times because they were surprised by the result, is that even though a lot of them went through with little or no detection, most of the alpha particles, that is, went through with little or no deflection at all, some of them deflected pretty severely, and some of them even deflected back again. So basically rebounded off of this gold foil. In fact, this was such an unexpected result, the comment that Rutherford made was, it's almost as if you had fired a cannon at a piece of tissue paper and the cannonball bounced back off of it. That was the view of how unlikely they thought that this particular set of results would occur. So what must be going on in reality then, is, for this to make sense, is that the actual positivity, or the main portion of the mass of the atom, must be contained in the center, must be contained in some sort of extremely dense pocket, because most of the mass must be contained in a small enough area to provide the density required for particles to hit and rebound off, or glance, hit, and deflect off at an angle. So that's now the more refined view of what the atom looks like. And there's been some refinements since then, but the overall idea here is most of the mass is all contained in a small core. That core is then called the nucleus of the atom. That most of the volume of the atom is empty space, through which we have these tiny negatively charged electrons dispersed in different areas, and that there are as many negatively charged electrons outside the nucleus as there are positively charged particles, whatever those were, and those are called protons, inside the nucleus. And then neutrons, which were discovered later, are also in the nucleus and just take up mass, but don't have any particular positive charge.
Because they have these regulations now that we call other aspects of electronics, such as therapy. And you really have to check the orders. The media says that you have your fingers push back with the media says that you have and then the tissues kind of baby Jesus to go out that absorption stage.